Good morning, everyone. Welcome to DEV306, embracing DevOps and learning how to automate operations. My name is Amjad Hussain, and with me I have Tyler Jones from Ancestry. And what you can expect from this session is we'll start by doing a quick introduction to AWS Systems Manager. We'll go over some key customer use cases, and we'll dive into some technical details around some aspects of Systems Manager, especially as they relate to automation and desired state and configuration management. And then Tyler will walk us through what Ancestry does, and specifically how they're leveraging AWS and some parts of Systems Manager to automate their infrastructure. We have a couple of demos for you, and then we'll end with a quick recap, and then hopefully we'll have 5 or 10 minutes at the end where we can have some offline questions and discussions here with Tyler, myself, and then there are a couple of other people from the team as well. Okay, so let's get started. We'll start with a quick introduction and overview of what Systems Manager is. But before we do that, actually, how many people, show of hands, are familiar with EC2 Systems Manager or SSM? Okay, so 10, 15%. All right. I don't know if you caught the announcement, but on Wednesday we launched AWS Systems Manager, where we took some of the functionality and features that we had in SSM, and we've made it more generalized. And we really think of this as a common operational sort of cockpit where you can come in and you have insights and control over your infrastructure. You can do management operations, you get visibility, and you can do administrative tasks as well. And so like I said, we sort of internally visualize or bucketize them in these 3 categories: grouping, visualization, and then actions. And grouping, really, if you think about how you manage infrastructure, how you really deal with any application, we tend to deal with them in logical groups of environments or applications or entities. And so we've introduced a resource group concept where you can leverage this. We've also exposed a number of first-class visualizations that help you collect data from multiple AWS services into a common place, including critical data such as patching and auditing and things like that. And then lastly, we offer a number of actions, which I'll get into in the next slide, around safely remediating and proactively taking actions on your fleets and instances. So let's spend a little bit more time on some of the specific capabilities of Systems Manager. The first one that we launched on Wednesday are called AWS Resource Groups. With resource groups, you can easily create groups, you can view group membership, and you can delete groups. These groups are first-class AWS objects, which means they have ARNs, and you can set tags on the groups themselves. We've also built a number of visualizations, like I said before. Some of them include things like built-in insights, which we'll demo later on, software inventory, compliance, as well as CloudWatch dashboards. And then I won't spend too much time on this. I'll just do a quick overview of some of the key capabilities of AWS Systems Manager. Run Command is a service that lets you remotely administer instances at scale. This is a cross-platform Windows and Linux service. State Manager is a configuration management tool that lets you, it's a lightweight configuration management tool that lets you make sure that your infrastructure comes up in its expected state, and then it stays in its intended state. Maintenance windows are a generic scheduler where you can register tasks and then take action on a set of targets. Patch Manager, as the name implies, is a service that lets you patch your infrastructure, again, Windows and Linux. And the automation service is a simple service that lets you automate common and repetitive tasks, such as army creation and things like that. The Parameter Store is a simple key-value store that lets you store data, including sensitive information. And Document Store is where it's a JSON and YAML represented store that lets you store actions and configuration. So that's a quick recap of what some of the core capabilities are. And in this talk in particular, we're going to focus on 3 things in particular: configuring infrastructure, automating actions, and troubleshooting. So So before we get started, I want to walk you through a typical life cycle of an engineer and an operator. You might start out by wanting to build out a new service. It may have like a set of web applications, a number of middle tier applications, and some databases. As soon as you get started, the first thing you want to do is, as these instances and infrastructure come up, that you want to configure them in a specific way. You worry that over time, either organically or an administrator and operator unintentionally changes the state, and so you worry about drift. You find that once the service is up and running, that you're doing repetitive and manual tasks, right? You may have to restart a service, you may have to go change a policy once in a while, and not only is it not a good use of time, they're also error prone, right? The more you do something, the chances are you may make a mistake or type a parameter incorrectly or something like that. Once the service is up and running, you might get paged outside of business hours, right? Especially if it's a live service, like most services are these days. There might be a problem in the middle of the night or during vacation, and you have to have safe, reliable ways of troubleshooting and remediating issues. So with those problems or those sort of things in mind, what is it that I, as an engineer or as an operator, want to do? The first thing is that I want to make sure that my instances are configured correctly. And I want to make sure that if in fact there is drift, that I'm able to quickly find out and get compliance reporting against that drift. I want to centralize all my procedures, things that I do repetitively once in a while, every other Friday. I want to centralize all that procedure in a common place that is auditable, that is versioned, and that's shared. And lastly, I want to be able to, like I said before, I want to be able to quickly troubleshoot and mitigate issues. So let's go through these three sort of phases in my life cycle. The first will be configuring infrastructure. Second, I'll talk about automating common tasks. And then the third thing will be remediating and troubleshooting. So when it comes to infrastructure configuration, typical scenarios that I've come across have been things like you're spinning up a bunch of instances in an auto-scaling group, and you want to make sure that some software is installed on it, some ports are configured a certain way, they're domain joined, or they may have, you may want to configure monitoring and alarming on those instances or that infrastructure. Using Systems Manager, you can author your configuration as code. You can set up so that automatically instances are configured at launch without having to do any manual intervention. And you can have automatic drift detection, remediation, and then reporting. So the first thing when it comes to infrastructure configuration is, well, how do I configure or express my intent? And the way you express your intent in Systems Manager is with a concept called SSM or Systems Manager documents. And documents are a JSON or YAML representation of what your configuration looks like. And I'll show you an example in the next slide. The nice thing about documents is that right at the top of the document is a parameters section where you can describe what the inputs of that document are. This is where you can dramatically improve or reduce the chance of human error by doing upfront validation. So for example, you can say that this particular document only accepts a string of this regular expression, or it only takes these 5 user inputs, and if a user accidentally enters something else, do a validation error upfront. Amazon publishes a number of predefined documents, and during the course of reInvent, we've actually published a number of new documents as well, and we'll continue to publish documents for common tasks and actions. However, documents are also shareable. So if you do come up with some documents yourselves, you can either share them across accounts within your own company, or you can share them publicly so that others can also take a dependency and use them. The other thing we announced earlier this week is support for YAML. Previously, SSM documents were JSON represented only, and now you can use both YAML and JSON. YAML obviously allows for easier commenting and editing, and it's just easier to read as well. Here's an example of a document in YAML. First thing you'll see is every document has a version. This helps you with compatibility and revving documents. There's a description, which is just a quick overview of what the document does. And then it has a series of steps. So for example, in this case, the first step says it's of type run document, it has a name, and it has a number of parameters or inputs that step takes. Here's another step where we're downloading some content from GitHub. And then the third step says, okay, now that I've downloaded the content from GitHub, I'm going to run, in this case, an Ansible playbook. Okay, so now I have created a document and I've captured my intent. How do I configure my instances so that they're bootstrapped the way I want? You'll use what we call State Manager. State Manager, like I said before, is a service that lets you do desired state configuration of your instances. You can use tag queries, which is super powerful because what it means is that you can have a document bound to a tag query, and anytime an instance comes up that matches that, we will apply that association or that configuration against that instance. The other thing that a State Manager lets you do is it lets you specify a frequency. So not only do we bootstrap the machine configuration on startup, but we can keep reapplying that setting over time. This is very important from a compliance and drift perspective. As an example, let's say that you want to make sure that a specific version of an antivirus software is installed on all your VMs. Or you want to make sure that a particular port that complies with your security policy is always either enabled or always disabled. You can express all those configuration policies inside a document and then use State Manager to apply them. And then lastly, like I said before, we report on compliance against that infrastructure configuration. So if for some reason we were not able to update the software or the port was indeed open, then we can report on it, and you'll see in the demo later on how you can use that to quickly find out what's in its expected state and what isn't. Here's a screenshot of the State Manager UI or the console. And I just wanted to call out a few things here. The first one being this concept of an association. And an association is a mapping between a document and a group of instances, right? So this is how you say that this firewall port check must be enforced against these set of instances. That mapping or that binding is called an association. You can see on the right, there's a last execution time or date, which tells you when was the last time this policy was checked for or enforced, and then a status, which says, did we apply it properly, did it fail or not? The other thing that we're pre-announcing here at reInvent is we're happy to share with you that very soon we'll be launching a cross-platform CloudWatch monitoring solution with Systems Manager. Previously, what we had was on Windows, there was a CloudWatch agent that was built into the Windows armies, but on Linux, there was no common daemon or agent that was present, and configuration of that agent was not very easy either. With this pre-announcement and this launch, what we'll be able to do is there'll be a common and easy way. Once you have Systems Manager enabled across your instances, there will be an easy way for you to just enable monitoring, specify exactly what you want to collect, again, in a cross-platform way. I actually think this is pretty cool because you can think about, imagine if you have a fleet of Windows, Linux, different distributions of Linux servers, and you want to make sure that all of them are collecting the right type of metrics, right? Maybe for Windows, you want to collect IIS logs, and for Linux, you want to collect some Apache and Tomcat logs and metrics as well. Using the CloudWatch component for Systems Manager, you'll be able to do that in a seamless way. The SSM agent, just as a quick sort of detour here, is an open source agent that is available on GitHub, and it has been for over a year. And we are also going to make the CloudWatch component open sourced as well. So look for this, hopefully sometime very soon. So now we've talked about configuring. So at this point, my instances are up and running. I can take comfort in the fact that they're going to be in the state that I want them to be. However, even with all this automation up front, I find that I have to do common tasks, or sometimes I have to do manual and repetitive things. I'll give you an example. Once in a while, you may find that a particular instance or a particular resource isn't behaving the way you'd expect. You want a common recipe or a common runbook through which you can go ahead and safely remove the instance from behind a load balancer, maybe do some forensics on it, and then either reinsert it or just leave it removed from the load balancer. Another example could be that maybe your IT policy is that anytime a new instance is launched, it requires a manual approval. That might be another example of a common action that gets done repeatedly. And lastly, you might want to automate. Another very common scenario is automating army creation. Every month, a set of patches come out. You want to make sure that you have the latest armies and updates before you start rolling out those Amazon machine images. Systems Manager provides an extensible way for you to automate your tasks. These workflows, like I said before, can pause and wait for approval. And we've recently announced the ability to also have rate control and safety built into some of these workflows. So the automation service in Systems Manager, you can think of it as a generic framework to convert these manual, repetitive, and error-prone tasks into documents that can be run. We provide a set of predefined automation tasks, or you can create custom ones. The automation service itself internally leverages Lambda, run command, as well as other built-in step types. The other service that I wanted to just briefly spend some time on that goes along with automation is also maintenance windows. Maintenance windows, like I said before, is a fairly flexible scheduling service that lets you perform routine actions, including running Lambdas, step functions, automation documents, or run command documents. The way it works is, as you can see on the screenshot on your right, that you create a maintenance window, you give the duration and the frequency of the maintenance window, you register a task, and you register a target. And at that point, it's just like a scheduler. When its time comes, it's going to run the task against the target, or the set of targets. Here's an example of a document with an approval step. The first thing I want to call out is that this first little snippet I have is the parameter section of a document. You can see that I've created a parameter called approvers, and it's basically just a string list of IAM users or ARNs. And then in my main document itself, there's a new step type called AWS approve, where you can say that, look, before this automation execution continues to the subsequent steps, it's going to wait here for an approval. And you can see how the approval parameter is passed into the step right there. Okay, so at this point, we have configured our infrastructure, we have automated some common tasks, and now we're going to go into troubleshooting and remediation. Troubleshooting, as you can imagine, is fairly complex. It can be fairly complex. It's open-ended, and sometimes you don't exactly know what you want to do until you've done it a few times when the service is running. Examples include log collection, restarting a service, maybe doing some maintenance operations on a node. These are the kind of scenarios that typically we face as engineers and operators. Systems Manager provides a simple and safe way to perform actions across instances. These actions are customizable, and they can be parameterized to reduce human error. And more specifically, run command is the service that lets us do cross-platform remote administration at scale. We have delegated access control, which means that you can use tag-based permission to specify who can run what command on what instances. I'll just spend a little bit of time on this because I think in the last 6 months, we've made a number of improvements in this area. Specifically, we have added the ability to do tag-based permissions on instances as well as documents. So what that means is that I, as an admin, I can set up a very fine-grained control like let Amjad run any document that is tagged with key equals web server value, or value equals something, and any instance that is in my non-production environment. But as soon as I try to run any action on a production fleet, it will fail. So it's a very flexible way for you to set permissions. The other nice thing about run command is that there is no need to open inbound firewall ports. Run command also exposes rate and error thresholds. Specifically, what it does is it allows you to specify maximum concurrency and maximum errors. And what that means is that when you're about to send a command to a larger fleet of instances, say 1,000 instances or 100 instances, you can say that do no more than 5% or 5 at a time. And if you breach a specific error threshold, fail the run, or stop the run, I should say, right? So this can be used to customize and make sure that you're not damaging your fleet if you're running any action on it. We've also announced earlier this year Amazon CloudWatch events support. For those of you who may not be familiar with CloudWatch events, I like to think of it as a multiplexing type of service which lets you have a bunch of inputs from different AWS services, and it lets you feed those into other actions within the CloudWatch event system. So in the case of run command, you can use run command as a target and an event source. So for example, you can say that anytime an instance is about to shut down, perform this action. I've heard from some customers that they use this type of thing for doing forensics or log analysis just before something is about to happen or something might have happened. So that type of scenario can be done with this. I've already talked about this, but here is an example of an IAM policy that lets you do fine-grained access control. You can see here in the condition tab where I have restricted the resources to everything that has a resource tag, tag key, and a tag value. On the right, you'll see an example where I'm trying to send a command and I'm using a target. And what we'll do in the background on the service side is that we will expand this and we'll see if it matches the policy or not. And if you don't have permissions to either the document or one of the targets, we will fail and you'll get an access denied. Okay. With that, I want to switch over to the demo. And the first thing we'll do is, how much time do we have? The first thing we'll do is we'll go over the new AWS Systems Manager console. For those of you who raised your hands who said that you are familiar with EC2 Systems Manager, the old EC2 Systems Manager existed in the EC2 console, and it will continue to exist for a while. Here, this is the new AWS Systems Manager console, which has all of the functionality from EC2, as well as the new stuff that we'll go over. So the first thing you'll notice is, on the left-hand side, there are a number of categories, and they roughly fall in the same order that we were discussing earlier today, which are there's grouping, there's insights, and then there's a set of actions and services. Let's start with grouping. A resource group lets you specify what a search criteria. So in this case, I'm going to say, show me everything that has this specific tag key and value, and you can see that it matched 2 instances. And then you can save it. You can even tag a group. And in my case, I have already created a resource group, so I'll show you. It's called My State Manager ASG. If I click on it, you'll see the same 2 instances that we were discussing before show up. The next thing I'll go over are the built-in insights that we talked about. We today have 4 built-in insights in the AWS Systems Manager console. They are AWS Config, CloudTrail, Personal Health Dashboard, and Trusted Advisor. And we felt that this is a good representation of some of the operational events that might be happening on the system, and we've brought it together in an easy-to-consume way. So if you look at, for example, AWS Config, now you can filter by a resource group. So you can say that for my autoscaling group, show me what AWS Config is saying in terms of config rule compliance. And you can see that there are 2 non-compliant rules for this. Similarly, you can view config history and see what are the number of configuration changes for the resources in this resource group. The other thing I wanted to show you was, similarly, we have CloudTrail entries as well, again filtered to the resource group. And we have Personal Health Dashboard for your account. So for example, I have a EC2 persistent instant retirement notification that's coming up on my personal health dashboard. Trusted Advisor also bubbles up interesting insights such as are there any cost-saving opportunities and things like that. And so we summarize all that and show it to you here. You can always click the View All Check Details and it'll take you to the Trusted Advisor console. Similarly, dashboards are CloudWatch dashboards, which are very powerful and customizable. Here I've created a couple of widgets within my CloudWatch dashboards for volume write ops, as well as users connected to my workspace. And I can directly open them in the CloudWatch dashboard as well. Here we're just bringing them together in a seamless way. Okay, so with that, I'm going to switch over to the CLI and show you some more scenarios. And specifically, I wanted to go over the state manager and configuring your infrastructure. So the first thing I'll do is I will show you a YAML-based document that I've put in GitHub. So in this case, it's a public GitHub repo, and you can see that this document is doing a few things. It's patching my instance, it's updating a driver on it, and then it's doing a health check at the end. And the interesting thing you'll note about this last step, which is the download health check script, is that it's not actually doing the health check in the document itself. It's referencing another script that exists in GitHub. So if I go to that second tab, you can see that this is a very simple script we just wrote that just collects the agent version, what's the software installed on it, and things like that. But it's meant to demonstrate that you can have a GitHub location which has not just the SSM document in it, but also a number of scripts. And so when you set up a configuration, we will at runtime go ahead and retrieve the contents of both the documents as well as any other artifacts, bring them down locally to the instance, execute them. Okay. So now that I've created a document and I know what it looks like, let me show you what the Systems Manager document looks like. So when I come to the SSM console, you'll see that over here, I am simply referencing, I'll make it a little bigger so you guys can see. It's a very simple document, and all it does is it just has a pointer to the GitHub location, right? So it just has a pointer to that YAML file that I showed you before, right here. Now that I have a document, we have an API called Describe Instance Information. It's also available in the UI that lets you view all the instances that you have under management. So in this case, I want to see all the instances that have a specific key value pair set up. It returns a couple of instances. You can see that it has computer name, instance ID, IP address, and a bunch of other information there. And then I can create an association. And you'll remember how the association was a quick way of binding a document to a target. So in this case, I have already created an association. And what I'll do now in the interest of time is I'm going to switch over to the new console and show you what the experience looks like. So here you'll see the association. It has an ID. And it has a bunch of information like what was the create time, when was this association last updated and last run, as well as what instances is it targeting. In this case, I've only targeted one specific instance. I can also go to the compliance dashboard. You remember how in the beginning I was saying that you can also get a holistic compliance information? You can see here that this dashboard shows me an overall summary of what my compliance looks like for both patching as well as association state manager. So if I drill down on state manager, you will see that there is 2 non-compliant nodes or instances, and there are 2 compliant instances. And if I go further down, I can even get a quick list of them. So you can see that I have a few instances here, and I can see the non-compliance or compliance nature. The last thing I wanted to show was using run command. This is also fairly straightforward, and in this case, if you just focus on this line, what we're doing is we're calling send command to a specific instance ID. We're giving it a document name, and like I said, Amazon publishes a set of documents. In this case, this is a fairly generic document that lets me run any shell script. In the parameters, you can see that for this demo purposes, I'm just running a bunch of ad hoc commands, like show me which file has a particular port open, or the service status, or just a list of processes. You can expose the concurrency that I mentioned before. So in this case, I'm saying go no faster than 50 and stop even if there's one error. And I'm also sending the output to an S3 bucket. This is very useful, especially if you want to combine all your output in a common location. That way you can do quick analysis offline. As an example, what I'll do is I'll switch over and show you a S3 bucket from a previous run. So what you'll see here is the full output is just showing up right here. And the other thing I wanted to show you is, if you look at the bucket itself, it's organized in a very logical or programmatically logical way so that you can easily automate on top of this. So for example, I have a bucket called Amjad IAD, and then reinvent is the prefix. And you can see that all my runs that I've done in the last, in the last couple of hours, they all have gone to the same place. I can discover them by simply saying, okay, what is the command ID? Prepend that, go to the instance ID, look at the specific document that you were running, and then it segments it into both output as well as error. And finally, you can see the same information also available in the console itself. So the run command console, as you'll see here, exposes the same information. It'll show you the instances that it was run against, and you can even get a very quick sense of the output. So right here, you'll see what it did, and you can get a quick view of the execution. Okay, with that, I'm going to hand it over to Tyler, who's going to talk more about Ancestry.
Thanks, Amjad. I'm really excited to be here. I'm super excited for all the new features coming, although it feels like every time I attend a session, there's at least 2 new features, so I'm going to be drowning in documentation when I get back. When they reached out to me to speak, I was super excited, and then my coworkers immediately started giving me a hard time. I'm a huge Apple fan, and they're like, so help me if you play Buzzword Bingo and turn into Tim Cook or Steve Jobs, you're never going to hear the end of it. So anybody playing Buzzword Bingo, this is innovative, it's beautiful, it's new, it's a subscription service. There you go. All right, so who are we? Ancestry, if you're not familiar with us, we are a family history and DNA company. We were founded in 1983 as a publishing company, which is like, oh, that's cool. And for most of you guys in the room, you may have been around. I was not. And it was really a lot of fun to step into this company. In 1994, the year before I was born, we actually launched the website. And I was like, sweet, this is going to be great. Go work for a real company. And then I realized there's a lot of technical debt and a lot of places for automation, which was really fun. Along with this, we have petabytes of historical records, which for me, I'm a data nerd. That's really cool. And it's really, really cool to see how we've been able to, in the last couple of years, I think about 3 to 5 years, we've launched our DNA analysis kit. And for that, we can actually go through, test your DNA, and see who you may or may not be related to. It's really a really cool feature. We actually just had a giant Black Friday sale, and I hope all of you guys in the audience got it. It's really, really interesting. And because of all of our DNA analysis, our data rate grows at an insane amount. And so we had no other option but move to the cloud. And so we're currently moving all in on AWS. Last year, the executive board and the company made the decision we're going to be all in by the end of this year. The scale we operate at terrifies me when they said do it in really 10 months. We wanted to be there before all of our holiday sales and traffic. So where were we before, and why was I so terrified? Well, we were all about old school data center operations. We manually racked and stacked hardware for days, weeks, years, 24/7, 365, somebody was at the data center. That wasn't terrible, but when you start talking about commerce spikes, that doesn't work. So we used all sorts of different things to provision data centers, or our singular data center, whether it was Ansible scripts, Bash scripts, Python scripts. We had hundreds of all these disorganized scripts all the way around, passed between different teams. And it really just kind of depended on who you asked on how your infrastructure got provisioned. In that, there wasn't a ton of error handling. So if something failed, we just kind of threw the VM away and started over and didn't really understand why it failed. And that led to all sorts of other different problems as well. It was very slow and error prone. We're talking days to weeks if we were lucky enough to already have the hardware for your VM. If it wasn't, you're talking, potentially months going through the procurement process. Very painful. And then my least favorite part, I really enjoy my sleep. Somebody had to get called at 3 a.m. when traffic starts spiking on Commerce and we need more VMs. Thankfully, that was never me, but I've been in that role before and it's just absolutely miserable. And then did I mention it was slow? I cannot accurately describe how painful and how slow this was until you've been in our environment. It was really, really difficult. We got executives on the phone screaming, I need servers yesterday, what's taking so long? It's very stressful. So we started moving to the cloud, and we decided up front there were some very key things we needed to have. We need the ability to scale quickly and efficiently, which meant I need to be able to provision servers very quickly in a very automated way and very reliable. 24/7 without a human behind the keyboard. That's what I strive for. If there's a human in my system, I want to eliminate it as fast as humanly possible because humans are notoriously unreliable. You miss a semicolon here, a comma there, and the whole thing comes crashing down. So the other thing that we started to realize is we had to do error handling right in our provisioning scripts. And then we had this really long conversation. I remember sitting in a meeting, how do we error handle? How many times do we decide to fail? What does that system look like? And we started going down the route of building our own provisioning system that would handle these kinds of failures. And then also on that other side of that, we have a decent sized fleet of Windows instances. I would say roughly 40-45% of our environment is purely based on Windows still. It kills me a little bit inside every time I have to RDP into something, but we're actively moving away from that, and I couldn't be happier. But because of that, nobody on my team knew PowerShell. I said, hey, I need help with the PowerShell, and I got blank stares. It's like, what? What is that? And so we realized very quickly, this isn't gonna work. So we went back to the whiteboard. We're like, well, what if we use user data? Well, that's great, but if you live in the Windows world, you reboot every time you sneeze at the machine, right? I need to rename the machine, there's a reboot. I need to join the domain, there's a reboot. I want to open a text file, there's a reboot. No, I'm just kidding. And so it was very slow and hard to test with user data because user data runs once on boot, you had to reboot. Oh no, now I'm done. Okay, half my script got executed. That's not what we wanted. So it was painful. And then teams would come to us and say, hey, yeah, the 400 VMs I provisioned, where are those? Where are they at? How long until they're ready for me to put into production traffic? My VP is screaming at me. I need to tell him something. Previously, it was like I think we launched about an hour ago, so go get a cup of coffee, go out to dinner, and come back tomorrow, and you'll have it. So we realized there's got to be a better way. And so we decided, you know what, there's this thing called SSM. We worked very closely with Amazon's Pro Service Consultant Department. Huge shout out to those guys, they're fantastic. We also worked with OneStrategy as well, probably the best private consulting firm that is an Amazon partner that I've ever worked with. And they said, hey, check out this thing called SSM, a Simple Systems Manager. And I just kind of raised my eyebrow. I'm like, what is that? There are other tools. There's Python, there's Chef, there's Puppet. We have those. We can work with it. And then they said, no, take a look. So we looked at it and we realized, oh, this is fantastic. It just started checking off everything we wanted. It had feedback and progress reporting through the console. I didn't have to have a developer sitting at my desk asking where his stuff was at. And the best part is it allowed customization of automation paths. I have a saying that even when you think you're special, you're not, and I can't support your special snowflake design. My developers hated hearing that from me. And now I can say, you know what? You want to be a snowflake? Here you go. Go to the console. This is how you do it. You can handle your own automation chains. And it's been really fantastic. Our teams have been able to innovate very quickly in that space now with that. Number 3, it worked with reboots. So Windows, I didn't have to code a locking mechanism and say, all right, I'm going down for a reboot here. This is where I was at in the script. Come back in and start. And then the other thing I'm going to mention there with it, it was a lot easier for our teams to maintain and edit. It wasn't just this amalgamation of scripts here and there and all that other stuff. We also make extensive use of auto-scaling groups and launch configurations in Ancestry. And the problem with user data and previous approaches to that handling through user data, anytime you wanted to roll out to an update to your automation chain, you wanted to install a different version of Chef, you wanted to drop a different version of Java on there, pull a different container version, you had to go through and update every single launch configuration and then start terminating instances to pick that up. It really didn't scale past a couple hundred servers, and we really had problems because we found out that we were actually making changes to automation quite frequently. So you might have been wondering exactly what do we use it for, and we'll go through here. So every single Windows VM in our environment, with the exception of our data layer, so SQL Server, things like that, are bootstrapped and provisioned using Windows. That's multiple thousands of VMs, right? They're all wrapped in auto-scaling groups. It's fantastic. Our infrastructure is one step closer to auto-healing now because of it. And then we've recently started rolling out across all of our Linux machines for anything that needs to be domain joined specifically. I don't know why you would ever want to join Linux to the domain, but we do it, and it's fantastic now with SSM because it took the headache right out of it. The other thing that our other operations group is using is doing Amazon machine image patching, and it's fantastic. Previously, we had 1 to 2 people. Their whole job was just automating and patching our InfoSecurity blessed AMIs, right? Because InfoSec wants you to be secure. It's this weird dichotomy. So like, hey, don't use any of the other AMIs. So it was fantastic. We were able to free up headcount to actually help developers get to the cloud faster. And then part of that, InfoSec came back and we're like, oh no, what do they want? Well, it turns out they wanted to audit patch levels. They want to see where it was. Specifically, this came out around WannaCry. And if anybody in here worked in the Windows world a few months ago when WannaCry, the vulnerability came out, that was a very bad day for us. It was like, okay, someone buy me a case of Red Bull, I'm going to be here till everything's patched. And it was great because we were able to leverage SSM patching. Unfortunately, it was a manual one-off process at that point to patch and fix that vulnerability in our environment. It was fantastic. And then the other thing that we've been able to start providing through chatbots and Slack and other things is the ability for teams to securely run specific commands against their instances as needed, right? Sometimes a developer will come to me and say, hey, I need to recycle IIS on this Windows box. I need to restart Apache on this Linux box. And we have a no developer direct access to production policy. So how do we support that? Do you go sit next to the operations guys? Well, they're busy fighting another fire. Yours is a minor problem. Let's just go ahead and expose that to you. And through the fine-grained access controls with IAM, that's fantastic, and they did exactly what we needed to. All right, so one of the great things that I touched on, I want to go into a little bit more detail here, is how we accelerate innovation with SSM. There you go, there's another buzzword. We went from 2 to 3 days in the data center, if you were lucky, if we had our hardware, and if everything was all signed up and pretty, to now we're on average 30 to 45 minutes per server in Amazon, from the time a developer says, I need a server, to the time it's in production. I can't tell you guys how amazing this was. And the other benefit we got is our automation has become inherently more reliable. As the great Ron Burgundy said, our data center automation worked 100% of the time, roughly 6% of the time, right? And it was just like, it might work. With AWS and SSM, we've gotten to around a 95% run rate of perfection, right? The other 5% is usually me missing a comma somewhere and then banging my head against the keyboard until 2 a.m. and then crying with relief when I find it. Then the next thing we got to was easier patch auditing. Before it was like, okay, we're gonna run this collection of PowerShell scripts and shell scripts, and then we'll aggregate it all into a CSV, and then we'll throw that into Excel, and then we'll make this pretty little pivot table for our executives. This is where our patch levels are. And now it's just like, here's a screenshot, there you go, right? It's also been significantly more flexible. We've been able to decentralize automation steps. I don't have to have every single team reinventing the wheel when it comes to how do I join my machine to the domain? How do I install IIS? How do I install Apache? Right? All these wonderful things my team can centrally develop and then teams can consume. I don't have to have a singular one Git repo with everything in it. So I'll walk you through some of our architecture here. So as you can see, we used to have this giant, ugly 150, 200 line user data script just to get things going. We've now dropped that down to a singular line in the auto-scaling group, and then it just initiates an SSM automation chain via the API on provisioning. Right? It's fantastic. The very first step goes and renames the machine. It reboots. And then it goes through and it joins the domain, reboots again. It downloads some Chef configuration files to hook it up with our legacy Chef files, our legacy Chef system. And then installs and registers Chef with knife to our actual the rest of our infrastructure. And then it actually runs the first initial chef run, which does a lot of automation for us. And then it reboots again. And then finally, InfoSec came to us and said, hey, can you patch stuff when we bring it up so we're just good to go? And we're like, oh yeah, we can do that. So now it patches machines. And then the other final step is it adds it to a code deployment group for our teams. Right? It's very hands-off. If they have a Jenkins box that they manage their own deployments with, it can register with that, or it can register with our centralized deployment system as well. It has been absolutely phenomenal, and now we'll get into the really fun stuff here with a little bit of a demo and show you kind of exactly what we're doing here. My demo here is going to be very simplistic as far as, let's see if it'll work here. Come on. It's not detecting my HDMI, great. So it's going to be fairly simplistic. I can't show you everything that we do at Ancestry because unfortunately our InfoSec department isn't as happy about that. So we'll go here. In our traditional EC2 SSM console, this is where we started, right? I'm really excited to use the new console. I've always struggled with pointing developers. When I say, hey, go look at SSM, they're like, what? Okay, go to the EC2 console. It's on your left. Scroll down. Don't pass go, but do collect $200, and then click this button here, and there you go, right? So we'll come here down on the left, and we can look at some of our automations as well. Right here, you have this wonderful interface that shows historical runs, runs that may or may not be currently in progress, and then their traditional, or sorry, not their traditional, but their status, right? You'll notice that during testing, I had several failures and other problems, right? It was great. So without further ado, let's go ahead and I'm going to show you exactly how to build some of this stuff and go from there. So the very first thing I want to do is build an automation document. So I'm going to create this document. I have a name saved over here because if I don't, I will type it wrong and then my whole thing falls apart. So we'll come over here and then we'll create of a type automation. This is fantastic because, again, it's all coded. It can be version controlled. I can collaborate on it. It's not on somebody's machine under their desk and some special voodoo, right? We can come in here, we can paste it in, and we can click Create Document. So to walk you through my architecture here, what we've decided to go with is, I want to say very plug and play. Our automation document is all it does is call other SSM documents or run command. We don't actually build any logic into the automation steps itself because we want to decentralize that. We want to pull it apart so we can actually manage in very singular deployable units, right? So now we'll go ahead and come in and I'll show you one of the other things that we're doing. Right? So we want to go ahead and create what I'm going to call Jenkins setup, right? And the very first thing that I need to do is come in and I want to rename the machine and make it easier to find. So you'll see here I'm using schema version 2.2. SSM schema versions are fantastic. We originally started adopting this when I think it was 0.3 or 1.1 was the only schema that was available. And since then we've been updating everything we can to 2.2 because you get so many more benefits. If you want to know exactly what those are, the documentation is pretty fantastic around that. So you'll notice here initially I have this thing called the parameter for an instance ID. What we've done in order to really keep track of all of our infrastructure at Ancestry and make it really easy to find, because we run multiple accounts, is we rename all of our host names to an instance ID. It also enforces the cattle, not pets idea and gets our developers moving away from the idea of this is my server. It is mine, I built it, and I love it. And then now it's just like, oh, it's an instance ID, it's somewhere, right? The next main step I'm going to be doing is I want to run a shell script. I want to rename the machine. Specifically this one, you'll notice I'm using a precondition statement. Because this is cross-platform, whether it's Linux or Windows, I can have PowerShell scripts in here, I can have shell scripts, I could have Python, and if you're crazy, you could even potentially run a Java jar in here. I don't know why you would do that, but there's that as well. So right here you'll see this is very simplistic. I then take the inputs of the run command, and I want to do some testing here. During my automation, I put in an echo statement to make sure my automation was getting run because I was struggling with it initially. And then now I'm going to go ahead and adjust the host name from the default localhost, local domain option, and then move it to the instance ID. You'll notice here that this is the parameter syntax. Double curly braces here and then a space. If you're familiar with JTwig or Jinja, it's the same interpolation style right there. And then I can go ahead and put ancestrydomain.com, which, yes, has a test domain in here, and then we're off to the races, right? You'll notice this is 3 lines. It's very simple. I don't want a lot of complexity in here because it makes it very difficult to scale out as we move, right? It's much easier, we've found, to have multiple documents we're managing rather than having a lot of centralized logic. We kind of took the lambdaized approach. One function does one thing really, really well. So the next thing that we'll talk about, and as I go through and chain all these together here, we'll go over here to the automation doc so you can kind of walk through exactly what we're doing. We're going to go ahead and rename the machine. We're going to join it to the domain. Not really, I'm just going to put it in a text file that says we did it. We're going to patch the machine. So you're going to get some reboots in here. And hopefully if everything goes well, that's the fastest way to ruin a product is demo it, right? So hopefully it all goes well. And we can set up Jenkins, which is really quite simplistic in our environment. We run Dockerized Jenkins as well, and we'll go from there. So we have our automation document in. Let's go ahead and get our Jenkins setup document in. And we'll go from there. So I'll create another document here. This one's going to be of type command, and it's going to allow us to do this different schema version. One thing to call out is automation documents are still on the O.3 schema, so just be aware of that. You can't just code one thing. But hopefully we get some schema 2.2 support soon. It's much prettier. I can version my documents, and that's going to be great. All right, we're going to go ahead and add our domain document, our domain join document as well. And traditionally, we manage all of these through our configuration as code, or our infrastructure as code layer. So I'm just going to quickly go through here and do this. I didn't want to pre-bake everything. I figured, if we do it a few times, you guys might actually remember something from the demo when you go look at this a little bit later. So we're going to go ahead and do the patch stuff. And you'll notice that I've named my stuff very specifically. There's actually a purpose to this. It allows us to do some interpretation in our infrastructure as code layer to link all these documents together. It's a very decent naming scheme, I think, that we came up with. So teams, again, don't have to learn everything here. And then finally, our rename machine step. All right, so now all of our documents are in place. Now you're thinking, okay, how do we actually use this? That's great, right? So I'm going to come over here. I'm going to go to an instances here, or instances, and I want to launch an instance. So by default, all the Amazon AMIs have the SSM agent baked into them. If you're running your own stuff, definitely, I highly recommend baking the image into your AMI. It's going to be really good, okay? So I'm going to select Amazon Linux, and I'm just going to keep it at a T2 micro. And the configure instance details. Right here, you get to see all the magic of a singular user data. All I do here in this script, if you guys can see that, is I set the instance ID by curling the local metadata API, because I'm going to need that for everything else. And then I'm going to go ahead and then start my SSM automation execution. Very, very simple user data. No more do you have 400 lines and, oh, great, where exactly did it fail? So I'll go ahead and put that in here. Make sure all of my stuff is set up correctly. And then we'll keep that regularly. And then we'll do a name tag here. And we'll go from here. So set up our security groups. And I believe that's the one we want for this demo. Yep. And then we'll quick review and launch here. So now we'll go ahead and launch it. We'll use an existing key pair that I already had set up pre-done for the demo. And we'll go from here. So now in the background, you'll notice there's this instance ID, and it's going to start launching. And so I'm going to talk you through what's going to happen behind the scenes here. As it comes up, it's going to make that initial user data call. And then after a minute or so, you're actually going to be able to see it in the console, and then you can actually track it as we're going through. Right? So we'll go ahead and we'll pull up the SSM console here on the side. Come down here to automations. And then we'll just wait for a second for it to start showing up. Right. This has been fantastic. On this console here, you'll notice you can see different steps if you're using the automation step, and it's fantastic. So you can see during some of my testing, I had renamed a machine, I had done a join domain. Now it's really also cool if it fails out here, you can actually get output from your commands and see exactly maybe a stack trace or things like that. So you can click the view the outputs here, and then for me, I abstract a lot of it away. Because I don't want to see it if it's successful, right? There's no use logging that data for me. So I just see a command ID, zoom in a little bit for you guys, a response code 0 and a status of success. So we'll come back and hopefully it's in the console now. You can see, or not. Live demos, gotta love them, right? So you notice here, I had one that had failed. And as you can see right here, I was struggling with IAM permissions. This is the fastest way I found to develop SSM documents, is actually come directly into the console and do them one step at a time. IAM is, of course, the major driver behind everything that we do, and I find myself that's the one that we have the most problems with when it comes to SSM documentation. So hopefully when we come back here, now it'll show up. Or not. Well. So luckily I have a pre-baked instance unless InfoSec terminated it. So I can show you the end result. You get this really awesome, very simplistic. It takes about 10 minutes for this particular one to run because of the patching process. And now it looks like now I'm getting blocked from InfoSecurity on my VPN. So trust me, it runs. You get a wonderful Jenkins box, and you go from there. So without any further talk, I'm going to go ahead and hand it back. Or actually, we'll talk about future plans real fast. The next thing coming at Ancestry is going to be using maintenance windows to patch everything 100%. We actually want to take 100% of patching out of the hands of a human. We want to be doing it 24/7, 365 for as long as the company's around. We don't want to be freaking out when the next WannaCry comes. We want to look at a dashboard and go, yep, 5% are vulnerable, 3%, 0%, sweet, now we're done. The other thing we've started to make use of that is also part of Simple Systems Manager is the parameter store for secrets. As we start talking about configuration, we have a lot of passwords and sensitive data, so that's been another great thing that we're looking into. And then as we look at optimizing into the cloud in the next year, we're going to be looking into using State Manager for configuration management. So you guys have been a great audience. Thank you so much.
All right. Thank you, Tyler. Good. So just as a quick recap, we're almost out of time, so I won't go through all this stuff. You guys can just read through it. But basically, Systems Manager, the key points I want to highlight is it's a collection of services that hopefully you've gotten a sampling of how flexible and powerful it is. We have integrated it tightly with other AWS services like IAM, CloudTrail, CloudWatch, AWS Config. And SSM is available in all public regions, including GovCloud. And we are working through our compliance and certification processes. And right now, we're SOC 1, 2, and 3 and HIPAA certified for SSM. And the SSM agent, like Tyler said, is on by default on all Amazon Linux and Windows ARMIs that Amazon publishes. All right, with that, thank you. And whoever has questions, just come on over. We'll do a little bit of a Q&A. Thank you, everyone.
Thanks.